today's talk is about the state of cloud machine learning. My name is Gad. I am the director of machine learning at DoiT. Peter already gave the intro to DoiT. I guess that some of you are our customers, so there is no real need for intro to DoiT. Just myself, I've started practicing machine learning at 2014. It's kind of 6 years ago, pretty early relative to that stage. I'm a Kaggle competition master and also a Google developer expert in machine learning. I used to be the only one in Israel, but now there is another great person who is another GDE for machine learning. And today's talk is going to be about the state of cloud machine learning. But maybe before I talk about the current state of machine learning, it would be helpful to bring a little bit of a historical perspective to where we are. So I'm not going to go back to the 30s and the invention of the neuron model, but rather to more recent history. In 1998, I think that's the first real application of modern machine learning or deep learning, where Yann LeCun, now he's from Facebook, came up with an application to identify digits, handwritten digits, in order to correctly classify zip codes on envelopes sent to the US Postal Service. And the idea was that using machines that teach themselves, you can actually do human tasks in larger scale and better accuracy. But it took about 15 years for the scientific world to actually come up with a better, with a practical usage of machine learning. For 15 years, I guess that the field of machine learning was kind of forgotten. Only in 2012, this guy named Alex Krzyzewski came with the first machine learning model that kind of resparkled the idea that machines can reach human level performance in cognitive tasks. And I'm talking about the AlexNet, which was able to correctly identify objects and images. Like take this container ship image and correctly identify that it's a container ship, or that this one is a cherry, and behind there there's a dog. So it was approximately 15 years since Yann LeCun came up with the concept of convolutional neural networks, and until Alex Krzyzewski was able to come up with the AlexNet. But jumping just a few years later to 2016, David Silver from DeepMind actually proved that machines can outperform humans in very complex or cognitive tasks, like winning Atari games, like playing Atari games. So I'm not sure if you're familiar with that research, but in 2016, DeepMind from Google and the specific person, the leader of the team, David Silver, showed that a machine can teach itself to play Atari games and actually outperform humans in games like Pong and Breakout and other computer games. So we're talking of a very brief growth, right? We are talking about something that went from 2012 to 2016. It's only 4 years. And if I would extrapolate from that, from the velocity of adoption of the science of machine learning, then you may think that by now every company should have been able to start implementing their own machine learning algorithms and integrate it to their system. So I'm going to give you a slight sneak peek to what customers are actually doing on the cloud. So as DoiT, we have visibility to what customers are paying for. We don't know what customers are exactly doing when they're using the service, but we can see that they're billed for a service. So I took some of the data and I've looked on what customers are paying. So you can see that 95% of our customers are paying for stack driver logging. That is used to store the logs, to analyze the logs. And that's pretty natural, right? sometimes logging is more important than the code itself. 85% of our customers are paying for storage, cloud storage. That is a blob storage that can store petabytes of data and give you very rapid access to it. Almost 85%, like just about the same number of customers, are using BigQuery, which is a data warehouse. So it's pretty amazing. 85, you can, it wouldn't be very accurate to say that 85% of our customers have a data warehouse, but let's say that something like 85% would be a fair estimation. So that is also pretty amazing, because when you think of it, Hadoop was released in 2004. And up until recently, big data was a very big issue for companies. So now maybe you can say it's solved, because you can see that 85% of the companies have adopted big data / warehouse technology. Cloud Pub Sub messaging, 63%. Maps API, you can see that about a third of our customers have geographical applications, and they're using Maps API. And this one is also interesting, Cloud Run. You can see that 18% of the customers are using a managed container service. So that brings me to the question of how many customers are actually using machine learning, if these are the perspective. And I wonder if somebody could try to give me an estimate. I know it's hard when you're doing that with an online meetup, but let's see if there is somebody brave enough to make an estimate. Maybe Czar, you try to give me an estimate.
Yeah, I'll say about 1 in 6.
One of every 6 customers.
Yes, some machine learning. Like, I mean, it can be experiments. Yeah, and you can post your ideas to the chat window.
So I'll just give you the answer. I've looked on. Oh, sorry, I've looked on some of the most popular machine learning services at Google Cloud, and it looks like 8.1% have ever used deep learning VMs. Click to deploy deep learning VMs. It's a good indicator of how many customers have used the deep learning images. Approximately 7.5% have used Cloud Machine Learning Engine to train and serve their models. Down there, you see Cloud Natural Language API and Speech API, which are out-of-the-box machine learning APIs. And if you look on a product that Google, like the flag product that Google is offering for machine learning, the TPUs that are supposed to replace the NVIDIA processors as the most optimized processor, as Google sees that, right? As the most optimized processors for deep learning, then you're only just under 2% of adoption. But it's not too bad, because if you look on the trends, you can see the trends in the past year. Maybe you zoom in. And you can see that the adoption is growing. We've got used to looking at graphs, I think, in the last few months. So it's not an exponential growth, I would say, but it's a fair growth. You can see, for example, Cloud Machine Learning Engine growing from 1.5% to up to 4% in the month of May. And also TPU here goes from just under 0.5% to almost 1% in May. And I think it's pretty awesome to see that there is a growing adoption of machine learning, and that the field is not yet saturated. But it brings me to the question of, if 85% of our customers have big data already sorted in their pipelines, they're using BigQuery, they're using cloud storage, they know how to store data, to transform it, to process it, to move it around, then why are so many customers are using machine learning? So maybe you've seen this graph before of technology expectations. How does the expectation trend looks like for a new technology? So when you think of that, when we were in just the beginning, where it says innovation trigger, then that might have could have been attributed to the year of 2012, where Alex Krzyzewski came up with the AlexNet and introduced to the world the idea that machines can outperform humans in very complex tasks. And then we started thinking that maybe machine learning could completely revolutionize the world that we're living in. Maybe it could completely change the way that that we're going to do software development, and maybe it could solve all of our problems. And I think that we've started hearing talks about how people are going to lose their jobs, and maybe taxi drivers should go and find another job right now, because soon enough we'll have cars driving autonomously around the cities. And the expectations came soaring very high, very quickly. But then, actually, after a while, we kind of understood what are the limitations of machine learning and what it can do and what it can't do. And that's, I think, also important to learn. And with time, I actually started to see our customers kind of losing faith in machine learning. I've seen CTOs of companies telling me that we've had a machine learning team in our group, and we've decided to let them go because we've tried for 2 years to implement machine learning, and we've decided that it's not applicable for our business. So there came like this decay that I've identified in the past months, I'd say. And I think that now we're kind of in the phase that it's settling. It's reaching the plateau. And what signifies this is maybe relevant to the next slide. So I'm trying to think of what are the hurdles, what are the challenges in applying machine learning. So if you were to speak a few years ago, then maybe some of you would have told me that a major issue is that companies still don't have a big data infrastructure. Maybe they don't know how to save the data, they don't have access to data, they don't know how to transfer the data, but we've seen that it's not correct. 85% of the customers have adopted BigQuery. So it's probably no longer the data issue. And maybe it's the lack of academic knowledge. Maybe we still have to research and come up with better models because the models are not good enough. But I would say it's not true. I think that the academic world has provided us with enough tools for classification, regression, data generation, generative models. We've seen enough examples of theoretical knowledge that I think that almost every company that I know can find at least one use case of these theoretical models. And so maybe it's the lack of trained personnel. Maybe we just don't have enough people to actually implement and execute these machine learning concepts and machine learning algorithms. But I would say that's also not true. It was very, very hard to find people that can do machine learning in the past. But I think that if you look at it now, the market is somewhat even flooded with trained employees. There are now many more people who can actually do machine learning and know what they're talking about. It's nothing like it used to be in 2014, when I would just say random forest and get a job letter and an offer letter for a job. So what is it? What is it that's missing? And from my perspective, it's the tools. I would argue that that's the tools. So if I would make the analogy for what happened in the software world, then if you were to live in the 30s or in the 40s, you'd have to be Alan Turing in order to write a computer software, right? But then after the advances in the computer science world, there started to appear some more advanced tools to write computer software. right? First came the assembly, and then more lower level programming languages like C, and then around the 2000 we started to see programming languages like Java coming out. So the more advanced the tool came, the more high level they were, the more integrated, the more encapsulated they were. It was much easier for many more people to start and implement computer software. And now you can actually go and develop a website, for example, without writing a single line of code, right? You can use a product like Wix in order to build your own website, and you don't even know what is HTML. So I think that machine learning is undergoing the exact same process, where tools are becoming more abstract, more simple to use, and more accessible to people that are not specifically experts of the math behind machine learning. So let's talk about actually the state of cloud AI. So what tools can you get in order to build machine learning applications on the cloud? So Google has a very set, I'm going to specifically talk about Google Cloud, but it's not, I would say that it's not binded to Google. You could find a lot of these services in other cloud providers like AWS and Microsoft. I didn't want it to become a comparison between the clouds, so I decided to focus on what Google offers. But it's worth mentioning that you can find a lot of these services in many cloud providers. So maybe we can start with the first and most intuitive start of a machine learning project, and that is something sometimes you need to explore the data before you start working in it. And the most common tool today to explore data is to write down a Python code and execute it using a Jupyter Lab or Jupyter Notebook. And the problem with Jupyter Notebooks is that you have to install them. You have a lot of dependencies. Sometimes you're dependent not only on Python, but also on NVIDIA drivers and CUDA drivers. Sometimes you need a small machine to just start experimenting with the data, just a few gigabytes of RAM and just a few CPUs. But then when you want to train your first model, it's not for production, but rather kind of experiment with that. You need a larger machine. So you need to have a flexibility in the machine. But you also you want to save time in installing all of these components, all of these Python images. So I'm going to share my screen. I'm going to show you AI notebooks. So maybe we can, I guess that you can see my screen. So if you don't see my screen, just tell me. So what you have here is the AI platform dashboard. And you can see here many tools that Google offers for machine learning engineers, data scientists, researchers. And here you'll find the notebooks. And the notebooks is virtually a virtual machine. It's just a virtual machine. I can start a new notebook. Let's say I'm looking for an image for working with TensorFlow 2.2, and I don't want to use a GPU. I can give it a name. Let's call it a meetup. And I can set where I want it and what network is it going to be part of. And I can customize the size of the machine. But I'm not going to change it, just going to go use the default. And in approximately 30 to 60 seconds, I will have the machine up and running. Just to save us a little bit of time, I've started this machine just before the session. And once the machine is already started, I can just connect from it with a secure connection directly from my browser and get to the Jupyter Lab. Pretty awesome. And it's already installed with Pandas and NumPy and Matplotlib and Seaboard and all of these packages that you need to start to work with in order to start working with. So I think that's like the very good tool to start working with, especially if you want to explore the data. I'm going to leave this session. Let's say that for some reason I decided that I do need a GPU and I've already started the machine. then it's just like a regular VM. I can decide that I want to add 2 GPUs, maybe, and maybe I would like to install the NVIDIA drivers. And maybe this machine I would like to increase. So now I cannot edit it because it's running, but I can also increase the size and decrease the size of the machine. Any questions about AI notebooks?
Yeah, so please ask your questions in the chat window.
Okay. Cool. So pretty clear. AI notebooks, really simple way of getting a deep learning image or a machine learning image. You have a lot of images pre-installed. And of course, if you need something to install something else, if you need to install something else later, then it's also possible. We have one question here. How do you get data into the notebook? So I think that a lot of people ask me about the comparison between AI notebooks and collabs. So AI notebook is actually a machine that's running within your project. So it can access a lot of your resources with a very, very simple authentication. So there is a connector, for example, for Python and BigQuery. So you can download data from BigQuery to the machine, or you can initiate or send API requests to services in Google Cloud. So it's really easy to connect with the data that's already in your project. One thing that is pretty awesome that you have inside is that the network that you have between the components in Google Cloud is pretty awesome. So you get a much better performance than if you're working with a desktop running, with a machine running on your desktop. Another question, are these notebooks versioned? So versioning of what you do on the notebooks is really important. Like a virtual machine, you can always create images and always restore the data to, or restore the image to the checkpoint that you've created. You can also create automatically create images. It has integration with GitHub, so you can git commit from the notebook, and then even if the machine is destroyed or something for some reason, maybe somebody shut down, maybe somebody deleted it, you still have your code in GitHub. So I hope that answers this question. Cool. So that's a very good entry point to machine learning. Being able to connect to your data, is important. Being able to allocate resources, dynamic resources, starting from small, growing to big. But that's cool for playing around with, right? It's not good enough when I want to think of a production environment. So originally I planned to have videos, but the add-on that I'm using does not support videos in real time. So I actually share my screen. I think it's actually better. So my next challenge is to start and train and deploy models for production. And let's see, how can I do that? Let's say that I've finished my research. I brought the data, I played around, I made some graphs and plots, I understand what kind of models do I need. Now I've written down my machine learning code. It's TensorFlow or PyTorch. It's maybe scikit-learn or any other code that I've written. And I want to send it to deployment, to training, but I don't want to handle installing the images, allocating the resources, cleaning up after the training. And why don't I want to do that? Basically, I don't want to do that because training requires a lot of pre-made installations that somebody else probably already did. I don't want to start making up my own images for TensorFlow training. But also because it requires a lot of resources, and I'm concerned that if I may forget to shut down some of the resources, I might be paying a lot for these GPUs running. So conceptually, what I want to do is take my code, send it to Google, and tell Google, okay, just go and train this model and bring me back a model, give me back a model. So for that, you will have the AI platform's jobs. Let's share the screen once again. That's top 3. So again, I'm in the AI platform going from the AI platform dashboard. And here you can see all of the training jobs that I've submitted in the past. So this one is an example for some training job that I've submitted. Once I go to it, you can see that I've probably used TensorBoard, the TensorFlow, because it has integration with TensorBoard. You can see here the trials that I've made. You can see that I've made 10 trials. For each one, I've got a different loss. I've tried these with different parameters, training steps and max steps. These were the parameters that I decided to run my training with. Since it was a kind of a long time ago, you won't be able to see the resources that are required during the training, but you could actually see pretty close to the training how many resources and what was the utilization of these resources. And it's pretty awesome because once you submit a job, maybe we can try this, show you a little bit on how you create a job. Basically, you can use your own custom code or a built-in training algorithm. Let's say that I want to use XGBoost, for example. Then I would choose here XGBoost. I would send the reference to where's my data, where's my training data, where's my training output, and maybe I would like to use specific validation data. So I would reference this maybe CSV that is in cloud storage. And basically, a few clicks later, I would be able to define some hyperparameters for the algorithm, or maybe give it a space of hyperparameters to go and experiment with. And a training job will kind of look like this. It will start running, and once it's completed with no errors, it will show up as green. Let's see if we have some questions about this now.
Yeah, there's one question.
Yeah, I find it hard to find where is it. Okay, I needed to shut down the sharing in order to do that. How? I'm not sure I understand. So do you mean that you have the team working with different techniques? I think that the question.
So what you've been showing sort of shows how it's easier for people with, I guess, less technical ability or less interest in setting up their own infrastructure and things like that. But then there's also the sort of statistics and math side of machine learning, which I'm guessing you'll get into with AutoML and things like that. That's also getting easier. But historically, where do you? That's my interpretation. Where do you see more problems, like in terms of mismatch of skills?
So I think that exactly the part, and I have a few slides on AutoML and higher level machine learning. I think that the AI notebooks that I've shown refers to the level of people that actually want to write down their own machine learning code. And this one is also pretty much to people who know what they're doing in terms of the internals of the algorithm. They kind of have to know what is XGBoost before they run it. There are tools that I will show in the next slides that are designed for people who do not have the mathematical background. So I think that the sophistication that Google has to offer here is to provide answers, because not every company could handle with just out of the box machine learning. Sometimes you really have to write down your own machine learning code. I would make the comparison to cloud functions. If I were to interview a backend programmer a few years ago, maybe a good question for the programmer would be, how would you write a web server? And I think that many programmers nowadays don't have to know what is a web server because they have Lambda functions and cloud functions and cloud run. So it's really easy to just write down your specific logic, and everything around it is handled by the cloud platform. But sometimes you have a specific requirement and your cloud functions do not work well for you, and then you have to bring somebody who's a real expert of web servers to develop something that is unique to your specific needs. So I think that AI notebooks and AI jobs and AI models that I'm going to show next is more dedicated towards those who are machine learning experts. But in the next slides, I will also show some tools that are for people that are less experts. And I can set it. If I had to choose out of the box, what would be the first model that I would choose? What would be the first service that I would choose? It would be the AutoML, but I'm gonna get to it just a little bit later. Let's say that I've trained my model, right? I've taken my code, I've submitted the job, Google set up the machines, they installed the images. I was only paying for the training time. By the end of the training, they kept me the artifacts and they kept for me the artifacts in cloud storage. And now I have a serialization of the model, a serialized model, whether it's a saved model or an XGBoost Pickle saved in cloud storage. What do I do with it? I want to start integrating it in my application, right? So I'd probably want to either do batch predictions and then being able to reference some cloud storage data and tell the model to make predictions on it, or maybe develop a web server. So again, for that, I'm going to show you again my screen. So for that, Google offers AI platform models. And what you see here is a model is a conceptual way of aggregating web services that have machine learning. So I can create a new model that would be, let's say that my company does ad tech. We do a commercial or advertisement technology for websites. And now I have a machine learning model that does click-through prediction, and I want another model that does customer retention or customer lifetime value. So I can create a model, and a model is just a conceptual way of collecting microservices that have machine learning. Within a model, what I'll actually have are versions, and the versions are managed web services that run machine learning in the background. So how do I create one of these? So I have many ways of creating these machine learning services, but one of them, for example, can be after I finish training, I can click on that and ask to deploy the model that came with the best results. Here you can see that I've had 10 trials, and they're sorted by the loss, and loss represents how accurate the model was. So I can click to deploy and tell it to deploy to click prediction. And when I confirm, it will just create a web service in the background without any specific requirements for me. I just have to define if I want auto scaling, what machine types do I need, and not a lot of knowledge in writing web services are required in order to create a machine learning web service. So this one I've created before. It takes about 2 minutes for the web service to be up and running. You can see here that you have visibility to how many predictions were sent to the models, how many errors did you have, how many requests, what is the model latency, and for many companies, it's important to get around a millisecond performance in latency. What's the total latency? Not only the model, but including the routing of the request around Google from the moment it reaches the Google and until the moment it leaves Google. And how do you reference this API? So very simple. you get, you can see here some examples on how to use Google Gcloud command to reference the model, or maybe how you can integrate a Python code using a client library, and you have client libraries in many other languages. And if you're not, if it's not good enough for you, then you still have the REST API. So we've seen how to train a custom code, or if you write down our own machine learning code, how we can use Google to train the model. And we've seen how we can use Google to host the model and serve the model. But again, that was a very good question. Like, what happens if I don't have very high machine learning skills? Do I still have to be Alan Turing to write code? Do I still have to be Yann LeCun to write deep learning? So in my perspective, and I think in Google's perspective, the answer is no. More people will be able to start using machine learning in the near future. And I want to demonstrate it with two tools. What happens if you want to use machine learning, but you have no idea of math and what is TensorFlow, and you don't want to start learning TensorFlow in order to just see if machine learning can work for your use case. So I've taken an example of a machine learning application that is based on NLP, natural language processing. And what you can see here is an example of this API. You can reference this example by going, by searching Google for Cloud NLP API. And what you can see here, I'm taking some text from, I was told it's a popular news website in Australia, the New Daily. And I'm pasting in this data here. And I want to see what happens if I take this recent data. So you can see here that first it identifies Australia as an object, which is as an entity, which is a location. And you can see here that channel 31 is also identified as, I think it's an organization, because it's in this light blue. And it also has sentiment analysis. It's a negative sentiment. I think that if you read the headlines, you will see that it's about them not having sufficient funds to keep themselves on air. So it's kind of a negative score in terms of the sentiment, and the magnitude is strong. So it's pretty confident that this is a negative. This has a negative context. You can also break down the sentences and see the syntax of the sentences. Let's see it here. So you can see the pronouns and everything. The nouns, the pronouns, the breaking down of the sentence, the semantic breakdown of the sentence. And additionally, you can actually ask Google to classify what's this content of the article, and you can see here that Google thinks that it's about art and entertainment, TV and video, TV shows and programs. So you kind of identified the words television and on air. You could have thought about a better classification, maybe something that's related to news and financial, but it gives you some context. You can also see that it's not very confident. But I think that what's amazing here is that you were able, if you're just a programmer and you have no real concept of what is machine learning and how does it work in the background, you just want to send your data and get results, then you can use machine learning APIs. Another thing is that I did say that data is no longer a problem, but actually I think it's false to say that, because this data that the model was trained on is specific to Google. They're basically scanning the entire web on a I don't know, on a minute basis. So Google has lots and lots of data that many companies don't have access to. So they can actually train the models for you, and using their data, you can actually do classification that is better than what you achieve if you were to try and collect the data and try and train it yourself. So the two advantages that you see when you use the machine learning APIs is both to use the data that Google has, but also you're using their knowledge and expertise in the fact that they've trained the model and just exposed the API to you. These models are configurable, so you can configure the way that you approach the model, but you cannot change the model itself. So you cannot decide that you want to train the data. You want to train the model better to be better adjusted to your data. But sometimes that is the case, and sometimes you do want to train a model on your data, but then you don't have. But then maybe you don't have expertise in machine learning. That refers to the other question that I got here. So for that, I'm going to show you my favorite tool. This tool is called AutoML tables. It's a part of a set of tools that Google offers in the field of automatic machine learning. I'm going to do it briefly because I see that we're kind of running out of time. So what is AutoML tables? Let's say that I have a table of data in BigQuery. For example, my Zendesk data, our support system data, which shows data that comes from questions that comes from customers. And I want to know which customers do I want to, which assignee is supposed to handle this ticket. So I have a bunch of experts working at DoiT, and somebody is asking a question about BigQuery, or somebody is asking a question about machine learning. And I want to automatically assign the question to the right person because I don't want to waste time in routing the message around the people until I decide who's the right person. So I have historical data of previous tickets and which person answered the ticket in the past. And you can see here which features do I use. For example, what are the comments that I have on the ticket, or what is the description of the ticket? And since we're based in Israel, then does the ticket have Hebrew? And what's the priority of the ticket? And eventually, what I want to do is classify to the correct assignee name. So I'm bringing in the data from BigQuery. I can tweak here the type of the categories, the data types, I beg your pardon. Maybe it's text, maybe it's categorical. It does support numerical data. And then all I need to do is just click here, set the budget for the training, and click here to deploy to train the model. So it's going to take about an hour this model to train. We're not going to wait this hour, but you can see here that I've pre-trained a model. Once the model is trained, you can actually see how accurate it is. So you kind of have to know a little bit about what is an accuracy and what is the ROC curve, but you can basically just skip it and just go directly to test and use, and test it against your validation data, and make sure that you think it's good enough for you. You can do batch prediction, online prediction, and if you also want to export your model, then today you're able to export your model and deploy it on your let's say on Cloud Run, or on your Kubernetes cluster, or maybe outside of Google. You want to use Google to train the model and then serve it in AWS because your data resides on AWS. So that's also possible. So I think that would probably be my first tool at Google. And if you ask me, that would totally be my starting point for any machine learning application for tabular data. I wouldn't go and start writing my own TensorFlow code. So going back to the slides, we've mentioned how you can explore data, how you can train data, how you can use machine learning out of the box. I'm just going to briefly mention Qflo. I think we don't have enough time to deep dive into Qflo, but what Qflo offers is a way of managing the entire operations of machine learning. You can basically set up the steps for building a machine learning pipeline, like collecting the data, doing the transformations, training, validating, and then deploying to productions. All of these steps today have to be kind of manually executed by a human, or maybe use Airflow. So Qflo is a technology that allows you to build pipelines. Amongst other things that it does, it allows you to build pipelines that will enable you to sort these components together and kind of have a way of controlling the entire machine learning pipeline. So that's another technology that you can today find at Google. It's in beta. It's only being developed these days. So if you're talking about the state of cloud AI, so you can definitely see that the tools are just being built right now. And these are, for the most part, these are the tools that you can find in Google Cloud today. So what's there for the future? And I think that if I'd have one technology that I would keep track of today would be Feature Store. You have the link down here, and a Feature Store is a cool open source library that is being developed to be Google Cloud native solution. And the idea behind it is how you can architect. And here we're not talking about, because up until now I've kind of talked about how you can build each and every part of the component of the components of machine learning, like trading and exploration and serving. And maybe I've discussed a little bit about Qflo and how it can help you build the entire pipeline. But it's more in the sense of how to manage the pipeline. Another thing that you may want to rely on when you start building your application is that Google will provide you an end-to-end framework for the architecture. How to collect the data, whether it's for training and collecting batch historical data, or how to collect the data for real-time inference, how to do the transformation, and then how to make sure that you don't have discrepancy between historical data and online data, and how do you not maintain two code bases for online and for batch. So that is something that is a very interesting and growing library to look at. I would totally start it and watch what happens as it grows. And basically that's what I wanted to share today.